Welcome to Creative World. In this video, we will solve Chapter 3 exercise problem number 3.11. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.11. Use nodal analysis to find current I0 in given below figure. This is the circuit diagram of given problem. Inside this network we have to find value of current through this branch labeled as I0, and we have to adopt nodal analysis technique. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. So using this equation, we can find out that figure N in this equation represents the number of nodes exist in the network. In this case, there are three number of nodes. 3 minus 1 will be equal to 2. So maximum 2 number of node voltage equations can be retrieved from this network. In next step, we have to label all unknown non-reference node voltage. This node voltage is labeled as V1 and this node voltage is labeled as V2. This node will be considered as reference or ground node. In third step, we have to assume all unknown branch currents along with their directions. Now we will apply Kirchoff's current law one by one on these two nodes to find out their node voltage equations. We will start from here. On this node, one current is entering 4 mA while three currents are leaving I1, I3 and 2 mA. So KCL equation for this particular node will be 4 mA minus I1 minus I3 minus 2 mA equal to 0. Here entering current is taken with positive sign and leaving currents are taken with negative sign. In next step, we have to replace these two currents with their respective equations and subtract 2 mA from 4 mA. Current I1 will be equal to V1 divided by 2 kilo ohm. Current I3 will be equal to V1 minus V2 divided by 4 kilo ohm. This resistance 4 kilo ohm is connected between two non-reference nodes. So potential difference across this resistance will be equal to the potential difference of these two node voltages. Direction of current I3 is from node 1 to node 2, which is indicating that node voltage V1 is higher than voltage V2. So the potential difference across this resistance will be taken as V2 will be subtracted from V1. Current I3 equation will be V1 minus V2 divided by 4 kilo ohm. Now we will multiply this equation on both sides with 4 kilo ohm in order to omit all denominator values. Product of 4 kilo ohm and 2 kilo ohm in denominator will cancel out with each other. Only 2 will left and that 2 will multiply with V1. It will become 2V1. Here product of 4 kilo ohm will cancel out with 4 kilo ohm in denominator. Only V1 minus V2 will left. Here product of 4 kilo ohm will multiply with 2 mA. It will become 8 volt. Now open these brackets and place this constant value on the other hand side of equal. The equation will become minus 2V1 plus V2 minus V1 equal to minus 8 volt. Add values having same variables together. The equation will become minus 3V1 plus V2 equal to minus 8 volt. We cannot further solve this equation, so we will leave it now and label it as equation A. It is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this second node. On this node, two currents are entering 6 mA and I3 while three currents are leaving 4 mA, I0 and I2. Entering currents are taken with positive sign and leaving currents are taken with negative sign. In next step, we have to replace these three currents with their respective equations and subtract 4 mA from 6 mA. I3 is calculated in previous step as well, which is equal to V1 minus V2 divided by 4 kilo ohm, while I0 will be equal to V2 divided by 12 kilo ohm. Similarly, I2 will be equal to V2 divided by 4 kilo ohm. Now, in order to omit all denominator values, we will multiply this equation on both sides with 12 kilo ohm. Product of 12 kilo ohm and 2 milliampere will result 24 volt. Here product of 12 kilo ohm will cancel out with 4 kilo ohm in denominator, only 3 will left, and that 3 will be multiplied with V1 minus V2. Here product of 12 kilo ohm will cancel out with 4 kilo ohm in denominator, only 3 will left, and that 3 will multiply with V2. It will become 3V2. Here the product of 12 kilo ohm will cancel out with 12 kilo ohm in denominator, only V2 will left. Now open these brackets and place this 24 volt on the other hand side of equal. The equation will become 3V1 minus 3V2 minus 3V2 minus V2 equal to minus 24 volt. Now add values having same variables together. The equation will become 3V1 minus 7V2 equal to minus 24 volt. We cannot further solve this equation, so leave it for now and label it as equation B. It is the second node voltage equation of this network. Up to this point, we have retrieved two node voltage equations. Now we will try to solve this equation to find out the value of voltage V2. We are interested to finding out the value of voltage V2 because if we know the value of voltage V2, we will be able to calculate current I0, and this is the required parameter asked in this scenario. So first of all, we will add these two equations together. Minus 3V1 and plus 3V1 will cancel out with each other. Minus 7V2 plus V2 will become minus 6V2. On the other hand side of equal, sum of minus 24 volt and minus 8 volt will become minus 32 volt. Now divide on both sides with minus 6 to calculate the value of voltage V2. It will become 5.33 volt. After finding out the value of voltage V2, we are able to calculate current I0, that will be equal to V2 divided by 12 kilo ohm. Replace V2 with its value, that is 5.33 volt. Divide 5.33 volt with 12 kilo ohm. Value of current I0 will become 0.44 milliampere. So the value of current through this 12 kilo ohm branch, that is labeled as I0, will be equal to 0.44 milliampere. So this was exercise problem number 3.11. Thank you. See you again in next video.